Hello, again, welcome to the Doppl Talk. I'll just get right into it. Building mobile apps, I think we have two broadly incompatible ideas. And one of them is that, fundamentally programming is the reduction of repetitive work, but we're repeating tons of work. And this isn't unique to mobile, but I think the scale is unique to mobile at this point. Games is close, but games is like a single UI, and I'll kind of talk about that later. So touchlab, I'm Kevin Galligan. I've been doing Android since before the G1 came out. And just till about last year or so, touchlab was only Android. And so most of our work was, copy our iPhone app. And we've done that for a ton of different companies. So I think we have a pretty unique understanding of the mechanics and the math of copying code, right? So cross-platform is trash. I think I'm going to hit that right from the start. And they really do kind of suck. Nothing's ever really come and been this amazing solution. If you asked me in 2012, where are we going to be in a few years? And I would have said just all web, obviously. So it's easy to start believing that that's not coming, when somebody's out there doing this all day. But I think it's one of those things that also it becomes easy to believe that, but we kind of in the back of our minds expect this is going to sort of change. And I think that's kind of happening now, right? So platforms are somewhat converging. And this is a very specific audience to be taking this message to. So I guess I'll caveat that a bit. It's not just going to magically change. But mobile is mature. There are two mobile platforms and one web platform, and that's it. And it's going to be like that for the foreseeable future, unless somebody's got some news that I don't have. That means years of stability, and that means developers have a lot of time to focus on very specific targets. And we have very forgiving devices now. I have an iPhone 8 and a Pixel 2, and they're amazing. So on the other side of this is millions of apps in each app store, which translates into billions of hours of developer time. So I think somewhere in the middle of that, this is going to start to be changing going forward, right? So today, most of the solutions are from the web, and that should be pretty obvious, right? There are an order of magnitude more web devs, according to Stack Overflow, at least. And they've had a decade to be looking at what mobile is doing and wanting to be doing that. So they've been working on stuff for a long time. And to be clear, anything that's JavaScript, including React Native, all that stuff, these are basically web solutions. And it's likely that that's what's going to be most of what cross-platform world is in the next, 5 years, 10 years, or whatever. But our positions on this are kind of the following. It's mobile first means mobile leads, and I called it that, oddly enough, because I agreed to do a Swift talk at a Swift conference, and that's just the name of the talk. It's a long story, and I'm not sure that that's the best idea for my next few weeks. But anyway, the message to them is, I'll get to the message to them later. I'm skipping ahead. But so we've been working on architecture and frameworks for years for mobile, specifically for mobile. So I don't think the solution, quote unquote, should automatically just come from the web, and I don't think everything needs to be JavaScript. So not that web dev sucks, but there's a lot of a largely different set of assumptions and restrictions coming from the web, and I don't think that's really what we should be doing. And I could be totally wrong. It could all be one big web thing in 5 years, but we think that there are going to be multiple solutions. When I get into these discussions with people, especially if they've had a few drinks, if I'm talking to a React Native person, they're like, well, why don't you try React Native? What's wrong with React Native? You hate JavaScript. And this is like a Google crowd, so I get a lot of people saying, you should do Flutter. Everything's going to be Flutter. The world's going to be all Flutter in 2 years or whatever. People tend to get into these arguments and really advocate for their platform and see it that way. But there's just going to be multiple solutions, right? If you have a largely web shop, you're going to be doing largely React things in your mobile. If you're mostly mobile shop, you're going to do something else. I don't know who's going to be doing Flutter, but I am also specifically from a particular position, and I don't agree. But anyway, a lot of places are going to pick something, and this is what we're doing now as an org, is going to talk to large organizations that are deciding what to do. And it's not so much hey, we should start looking at these things. It's they've decided to pick one thing. And my Swift talk is about this. There's a lot of web solutions. We're building sort of an Android solution. The Kotlin native stuff is coming, and it's going to be really interesting, hopefully. Nobody's seriously working on Swift for Android or Swift for the web, and I'm going to guess that Apple's not going to spend a lot of time on it, so it's going to have to come from the community, which is part of this talk is a little advocacy for that. like I can't see the future, and I have no idea. Like if I could see the future, I frankly wouldn't be here talking. I would be in my private island or whatever. So, but I can tell you what we built and what else we see is happening, and then we'll just have to see how it goes. And then also before we get too into like the cross-platform anger, rage arguments, it's like it's not that big of a deal. I mean, like we're all smart. If we have to learn some new tech or whatever, if we pick the wrong horse, like nobody goes to jail. I mean, it's like whatever. It's just interesting to kind of work on these big problems, and we have some different ideas, and they're fun to play with. So enough of that. We're going to zoom right in from 10,000 foot to what this thing actually is. Doppl is Android-centric code sharing. It's a very Android-leaning code sharing solution. We try not to say cross-platform as much as possible because it's a ruined term. Basically, if you say it, people immediately kind of freak out. And then also, it's not really accurate for what we're doing. It's built on top of J2OBJC, which converts Java to Objective-C. This is made by Google. They use it in a lot of big stuff, such as Google Sheets and Inbox. It is very stable, version 2.05 at this point, but it is also, I think, very hard to use for the average developer. There's kind of make files that you use. I think they're trying to shoehorn some Bazel in there. It's very unfriendly with Xcode, yada, yada. It's also just logic. So they very specifically try to keep out of anything platform specific, a lot of specific. Anyway, so J2OBJC is the Java runtime, which includes the stuff you would kind of expect. And then like a tiny bit of Android, let's say log, and I think another thing. And then some libraries, so JUnit, Mockito, etc. What we're adding into that is a greater plugin in library format, so you can distribute your own dependencies. A build system, obviously, it's very familiar to Android developers. And then this interesting thing, which I'd have to spend a little more time explaining at some point, but we took a bunch of Android open source framework and implemented those things on iOS. So SQLite stack, shared preferences, a little bit of the context, threading, some message queue and looper and handler, and some other stuff, and trying to pick things that you would commonly use in your apps and some frameworks that are very popular that also make sense in the iOS context. So there's no service or content provider. They just don't really have any meaning. Then with a little bit of testing support, there definitely needs to be more, but this is kind of what we're working on. There's an instrumentation JUnit runner, so you can do some stuff with context and run database queries directly. There's some helper classes. The whole idea, though, is you can take your whole testable thing on Android and run that in iOS to verify that what you've made, shared code, works fine, right? That's the goal. So also a bunch of common libraries, so retrofit to RxJava to JSON Dagger, the architecture components, RoomDB, all this stuff. Originally, we planned to have like a whole bunch of libraries, but then we were like creating libraries for stuff we'd never use. So that's kind of pointless, but we're going to try to make the documentation pretty straightforward to create your own libraries. For example, the day after Room came out, I got the sources from the source Maven repository, and we had Room working in about 90 minutes. So it's pretty doable if you know what you're doing. Then some Xcode support, because J2OBJC really does not play well with Xcode out of the box. So what we want to do is essentially run this thing, run a CocoaPods thing, and then you can talk to your code from Swift, and then there's like a minimum you need to understand in between all these steps. So why all this stuff? And when talking to folks about cross-platform, the arguments tend to be very much share business logic or try to share everything. And we're adding a little nuance in there that I think is important, which is being also able to share architecture. There was a blog post recently by Pixplicity, and we know these folks, and they're great, but it was very, rah-rah, like we're still native folks, and they made some points I agree with, but some I thought were too much, like saying that Android and iOS are different, and I think that this is like a completely wrong assertion if you're talking about not UI. So Android and iOS outside of the screens and what they do specifically in the platform are really, really similar beasts, right? They both have threading. They both come with SQLite. They both have local files that you can write to. They're both very Unixy. They do networking. They do GPS. These things are remarkably similar for the purposes of what you need to do as it relates to architecture and data and all these things, right? And architecture is hard. How many libraries deal with architecture? How many talks do you go to about MVP versus MVVM versus clean, testable architecture, all this stuff, right? We kind of talk about it all the time, and Android and iOS are similar under the hood. So recreating architecture, if we can avoid that, I think is a valuable goal. So what we built kind of looks like this, right? You've got your fractivities and your Android native stuff, and that's fully native Android that you're going to code on the Android side. But the rest of this, to a large degree, can be shared over to iOS, and then you just kind of code your native stuff over there. You know, and like MVVM isn't really specific to Android versus Viper isn't really specific to iOS. You know, I think these are just what the communities tend to prefer in their, you know, conference echo chambers. Like, we have one, we're here, we're talking. You know, this is kind of what they like, but they're not really specific to the platform. So I think they're shareable. But not shared UI, of course, because that's generally not gone very well. In very specific cases, such as an expense app that you can't avoid using inside your company, like, things work fine. This came from a GTK example of a cross-platform mobile screen that they were, like, excited about. It's like, it's amazing, right? So, you know, they work, but they tend to be horrific. And, you know, and a side note, React Native is not shared UI. I think that was a common misconception that I had at the beginning. A lot of people also have. You're going to wind up doing a lot of platform-specific coding. There are libraries trying to change that, but, you know, again, it's the same problem. And the last point, like, we're at an Android conference, so if shared UI was something everyone was really excited about, we wouldn't be here. So, moving on. Games, really quickly, and it's an interesting point. Games generally have one UI because it's a totally different universe they're trying to create, and I think games, for the most part, don't recreate their code in any context, right? Maybe little bits for the specific platform, but it's mostly shared. So I think it's nice to think that if we can just quickly solve a mono UI problem for mobile, then this whole thing goes away, which I feel like is what Flutter is trying to do, and I'm not sure how that's going to go. But that's it. I'm not going to bash Flutter anymore. So moving on. So points of interest before we actually get into code. A couple of things to keep in mind. So the idea behind what we built is there's very smooth interop. So the calling between shared code and Swift and back, it's just like another library to Swift because it is literally just Objective-C. There aren't any weird barriers. There's like the same runtime. It's the same memory universe. So if you need to talk to native code from your shared code, you just make an abstract class or an interface, and then it just can talk to it like anything else. And another thing that's really important for this conversation, the Android side's 100% native. And that's something to think about, right? There's a big impact on development efficiency and risk with regards to that being the truth. You need rules. You have to separate your UI and your logic, but I think that those all kind of dovetail with best practices for testability anyway, so it's not a big deal. So very quickly, we're going to do MVVM on iOS with a feature of the droidcon app, sharing reactive architecture with the very popular libraries that you're about to see. So this is the droidcon app. When you click on a speaker's thing in the app, and again, you can't get it unless you download the straight link because Google Play was really cool the past couple days with their restrictions, but whatever. If you click on the app, you'll see the speaker detail. And we start with a view model coming out of the architecture components. And we subscribe to a flowable that's going to give us updates on the user account data, both when you first get it and obviously if anything gets changed remotely, it gets pumped through there. And then that goes through a fine user interactor and some other logic, but winds up ultimately at a room DAO, returning a flowable. Then that comes back and it goes to this compose thing to set up your different threading context depending on what you're doing at the time, because you also want to be able to inject different transformers so you can do different threads on tests and the main stuff. That all boils down to not really important about that specifically, but I'm demonstrating that this is kind of how some folks would suggest you build any app on Android using this kind of separation of architecture components. So back in the view model, again, as mentioned, when you talk to something native, it's an interface or an abstract class, and we're going to be talking to the UI, which is native. So we create this interface, which just says, I had a problem, find user error, or the user was found. And we wire that in. This is share code, and we just have it subscribe to the flowable, and it does those things depending on what happens. There's a quick aside about a compromise that you have to make with this framework, which is we would return like a reactive artifact directly to the UI, but anything with generics doesn't translate super well into Objective-C and then into Swift. Like, it technically works, but syntactically it's like can be awful. So we just kind of do everything in hard code and then without any generics, and then it works. I mean, we're kind of working on that, but anyway, that's why that looks like that. So, in the Kotlin UI side, we open up with wiring the view model. We've implemented the host with this class. If there is an error finding the user, we show a message and close the activity. If we find the user, then we go do some UI shit on the Android side, which we won't get into. And then on Swift, you create the view model, you wire it with self, which again, we're implementing the host thing, just like we did on Kotlin side. And if you have an error, you show an error. We're doing less here because it's a sample app, so who cares? And again, if you find the user's found, you do some iOS UI shit, which we won't go into. But they functionally work the same, and they look like the same piece of data to the two different platforms. Show you some dependencies in how these work. There's, we've got retrofit, and we have the JSON converter and the RxJava adapter, and then we just have Doppl equivalencies for these put in there. And the same thing with RxJava 2 and RxAndroid. In the Dagger part, we have an annotation processor, and that's just making straight Java, which we just then put through J2OBJC as well. And that all works together. There's some config here that I should have taken this slide out because it's not interesting. Just go try the sample. Anyway, so the point is sharing is easy and it performs well. We've done some tests with SQLite, and iPhones sometimes beat out the Android phones running Android code. If I would like to talk to people who I've talked to some people who just are like, well, the architecture is not that valuable. What you're doing, it's really all UI, and I just kind of want to understand their arguments. But I'll leave it at that. Please, talk to me after class. So we're going to go into sort of the business purposes behind some of these things. And essentially, before I get into this, I'm kind of giving out concepts that I kind of wanted to start to be part of the discussion because I think that they're glossed over and not fully really thought about much. And one of the big reasons that we're doing this is developer efficiency. So by that, I mean, it's something that's hard to measure, but I think it's an intuitive concept for most developers to understand. For any given feature set, say like V1 of an app, the relative time it would take to build that using different frameworks. As a simple example, let's say you're writing a string parser in Kotlin, like it might be like this, right? In C++, it's something more like this. Or you could code it straight in assembler, and it's a little more like that. It's just a basic concept that I think everyone should intuitively understand. And by the way, when I was doing a lot of the SQLite code, there's actually an AOSP, there's assembler code that's doing some really, really interesting stuff that was frankly awful. And then this is just my favorite tweet of the year. I thought I'd throw that in there for a slide. Anyway, the point is, there's like math and charts, but it kind of doesn't really matter. You understand the basic concept. And it relates to mobile development in the sense that native tools are best. This is like our baseline assumption. So for general app development, Android Studio and Xcode are your best options, and by a reasonable margin, not just a little bit. For example, if I was going to build an app-only app and I built it with React Native, I would be wasting some significant time versus building it in Xcode. I would imagine some React Native fans wouldn't agree with that, but I think, the majority of people would say that that's likely to be true. And it's not like a quantum reality that's true. It's just that Apple and Google spend a lot of money and time to try to make their platforms the best, both for experience and for the developers building for those platforms, for obvious reasons. Why Facebook is building React Native is a whole different question. So anyway, when you use a third platform and it's not performing optimally, we call that the platform tax. And these numbers are highly contested. I just kind of say even just for one Android or iOS, using one of these third-party frameworks, you're really going to wind up adding 25% of time or more, right? And it's not just because it takes longer to build a screen, but it's because something doesn't exist, or you run into a build issue that you can't find help for because far less people use it, or whatever, right? When I give charts about that, it's kind of, I don't think the representation is very clear, so I just kind of came up with this before this talk. Was like, imagine you had something that wound up taking 3 months to building it in Xcode, right? If you built it in Xamarin, like your 3 months is going to be like this. This is what platform tax literally means, like just more time to get to the same thing. And maybe if it's really bad, it's something more like that, right? So which platform takes longer to build for, Android or iOS? And haha, it's a trick question. It's the first platform because you're spending an enormous amount of time doing your architectural discovery and churn, right? And then you're talking to the server API people and doing the negotiation about why their docs are old or whatever you're doing, right? And a lot of this is obviously coming from a consulting perspective. These are things we go through on every single project. But they're just the technical things. The really time-consuming things are iterating on product, right? Agile exists because people don't know what they want. And you spend a lot of time on waste, but it's valuable waste because that's the lessons you learn. And the marketing team that we have now really put it well. It's like these are out of order, but I'll just say it anyway. That waste is really your product differentiation. And the more that differentiation costs to get to, the worse things are. So you really want to be able to iterate on product as fast as you can. Building the second platform is a whole different, it's not even remotely the same amount of time or effort, kind of. So, and the platform tax is on everything. If it takes you 30% longer to build something, that includes all of your iterations and your cost and all your bullshit, right? So the idea behind this is it doesn't have any tax, right? You're building on Android. As long as you keep some rules in mind, it's straight Android using Android tools and libraries. So you iterate on product, you share your logic and architecture to iOS optionally, some, a lot, very little. And then that's just helping you save time, cut down on bugs, all those kind of things, right? So, this is where the slide was. Product differentiation is the iterations on it. And especially for startups, the goal is to iterate as fast as possible and you hopefully get to a product market fit before you run out of money. I mean, that's how that works. The other side of the business thing is risk. And this is coming more now into being obvious to us as we're talking to these large corps about what they're doing. You have these organizations with thousands of developers that are not these AAA, everyone knows about the apps, at a first name basis. These are more of these second tier of things. They just have legions of people and they're wanting to work on stuff, right? Management in these companies, they have very scary decisions and they don't really understand what they're talking about, right? So they're worried about all kinds of risks, but it's just not just technical. It's the development efficiency stuff, like security stuff. They'll give you vague things about why they can't use React Native and no one will explain why, but they're just kind of worried about making the wrong choices, right? Never mind hiring and training. Again, I was sorry, I wasn't going to talk more shit about Flutter, but trying to explain to someone who is in charge of 2,000 Java devs by why they should all learn Dart and rewrite their whole app is it's not even remotely on the table. Cooperative sharing, which is what we're talking about it's the result of smooth interop, and sharing is optional, right? So if you don't feel comfortable sharing the code that's touching the network, you just make an interface and then you implement it on both sides. If you're 2 weeks out from release and you have some problem with the shared code, you just don't know what's wrong, you just code around it, right? And you push the code out and you worry about it later. The whole point is you're not making what we call capital B big decisions. You don't have to decide to adopt an entire framework and hope it works. And the Android side is 100% native again. And if we're all honest with ourselves at an Android conference, Android is the riskier platform to deliver things on. And talking both out in the field, runtime support, all the versions of things, that kind of stuff. So if you're going to put all your risk on one side, I think it's better to put it on the other side. And this also doesn't add any bloat. So Instant Apps doesn't have any weight limit problems, right? And most of growth is going to happen in, countries that are less wealthy, and that's where really 80% of the world is going to be using Android. Their network usage costs more. Their phones are cheaper. They have less space. You want to be very delicate in that world. And I keep hammering these points. I'm just going to keep going. I feel like I'm at a technical conference giving you business stuff. But one thing that is true, if you wanted to build something and not have to risk it at all, you would just build two native platforms, right? Built an Android and iOS thing. So the way we're looking at this is starting from that assumption and then adding efficiency on up without introducing a lot of risk, as opposed to making a big decision where you go, I'm going to do everything in Xamarin. That's kind of our baseline thing. So all that to get to, look, high efficiency, low risk. That's what we're working on. And, that's what we have out now. You can go use this, right? It's not really sexy, I found, in the last few months to talk about Java and Objective-C to Android developers or anybody. But these are technologies that are used by major apps at large companies, and they're very stable. So it's something to at least take a look at. So I guess why should you care? Your team, if nobody's talking about cross-platform stuff, then you kind of don't really have to worry about it. Although when we're getting brought into some of these orgs, like we go meet with their Android and iOS teams, and they're just like, yeah, we're not doing that. We like Swift or Kotlin or whatever. But it's the web teams that are going to management and saying, hey, we have all these awesome tools, so we can just do this without having to make two apps, regardless of the performance of those things that nobody really has a good handle on. So keep your ear to the ground. That's how, how many times we've gotten those conversations. It's kind of funny. But at the community level, and this gets into the next slide, which is Kotlin, this stuff's happening, and if you want to have these kinds of solutions, they're going to be much more feasible much sooner if the community gets involved and works on them. And that's, so now is the time to get into it, right? Kotlin, so we just came from Kotlin Conf. We've been keeping an eye on Kotlin native, but for a long time it seemed kind of odd, and they weren't really focused on this stuff. But we started to get to know the team personally over the last few weeks, and they're definitely working on it. It is super, absolutely, I can't stress this enough, not ready to work on right now. Do not try to make an app. I will tell about the app we tried to make, but they're moving very, very fast. So obviously, there's been talks about this. Jake's talk was yesterday. There's JVM and JS as two targets you can potentially build Kotlin towards now. But then, putting the native under there, these slides were done like yesterday, so they're not entirely polished, but we'll just go through them. Putting the native under there, that's what we're talking about. And then also WebAssembly, which I have a sample working on. I took out of their native code, and it's on my website. And I don't know if that's ever really going to happen, but if it does, it's really cool. Like, you can distribute binaries to the web, and you have multi-threading and all this kind of stuff. Not ActiveX or Java applets, like legit things that you can run. But we're going to focus on the Kotlin native now. So today, the way it works is you point Kotlin native interop code at various Objective-C headers. And it allows you to call that from inside Kotlin. It is not fun. We started working on a Kotlin native app, and it was really kind of horrible. But again, like how we're doing this code sharing stuff, what they really need to do is more like this, where you can build a library that you can then call from your shared, your Swift side, right, as if it's just in the library, which is going to make building your UI in Xcode straightforward, because that's what Xcode is really good at. And I've talked to the Kotlin native team, they understand trying to compete with Xcode on that is just stupid. And also, obviously, you have to be able to do this. I'm assuming that'll work as well. I don't know what they said publicly at Kotlin Conf, and so I won't get into what they said privately, but just assume this is happening. I don't know when, but it's coming. So, but we're going to need to have Kotlin libraries that are native friendly. It's really hard to express how difficult some things are to do without the JRE available underneath it. So if you're working on Kotlin libraries, be aware that this is coming and something that you're going to hopefully make compatible. And again, like, I don't know when this is all going to happen. I think talking to them that a year from now you'll have something that's reasonably stable and workable. But they still have a bunch of stuff that has to get sorted out, like just basically figuring out the memory stuff. I mean, are they going to do ARC kind of things? Are they going to have some kind of garbage collector? Probably not. So it's a different world and there's a lot of problems. But they're definitely very aggressive about it. But also reach out to the native team and start talking about it. And I can't stress enough, really bug for the things that you want, like, hey, we don't care about Windows Desktop as much, so they don't spend too much time focusing on it. Here's the Kotlin Conf app, and it is available and you can build it. However, if you don't know a lot about Xcode or how Kotlin native works, it is not going to be pretty. And they really didn't do anything with shared logic underneath. I think they wrote some core data specifically to hold their data, and then they wrap it. Like, it's doing a lot of super manual work. So this is kind of next slides about what Doppl is doing. Does it even fit into this world? This is what our app now looks like for droidcon. And we were trying to make a Kotlin native app for droidcon, right? But what do you do? So we actually just exposed this J2OBJC output, and you can wrap it in Kotlin and call it in a very similar way to how you call the Java stuff. So it was it worked. We were going to be the first Kotlin native app in the App Store because the Kotlin native team had never released one. So we were like frantically working on it, and it does function as a blog post about it. But then I found out from them they were going to beat us, and there's no point in second, so I stopped. But to be fair, we were calling into the architecture components and retrofit and doing all the stuff using the Doppl things inside of the Kotlin native app. They had to wrap like curl. And again, write, core data things that, I don't know, that's not shared code. You're writing that in Objective-C. So, and I think going forward, if these stacks work out, it'll be something like this, where if you have some Java code, you can share it. It's all kind of working together. Yada, yada, yada. These slides kind of trail off. But the point is, they're philosophically very similar solutions. And this is definitely the two things that we're looking at and hoping become very usable to build things. And it's a very good option to go back with like two people who are saying the only thing available is React Native, so we should use that, or whatever. So hopefully these things are really going to be good in a couple of years at most. But again, it's like we need the libraries. We need people to talk about these things to bring them sooner. Or it's very possible, that the Kotlin native team decides that they're going to, put the brakes on it because nobody's talking about it. So get out there and get really excited about it. I think that's what should happen. And I ran out of time. Check out Rust. It's pretty cool. I after seeing how it handles memory and cross-threading like communication of objects, I'm immediately like, I don't know how other languages aren't trying to just shoehorn that in because it's kind of amazing. And I know some of the Yelp team is putting some of this in there, I think. But there's not a lot of people doing mobile with Rust yet. And so the Stack Overflow help is probably going to be like non-existent. And finding a competent Rust developer to come join your team is probably a little bit of work. But there's no like runtime bloat at all. It's very easy to like share very performant code inside your app. And as an alternative to C++, it's kind of amazing because I think I haven't done anything with it yet besides samples, but the Slack team put out a blog post about how they're sharing their code in C++, and it's good to see that it worked, but I would never recommend that as a first choice to people just because of what it is. All right, our status. We are in technically more, technical preview, but I only called it that because I didn't want to deal with direct support requests. But obviously, the underlying tech is very stable. J2EJC. Our tools, we're using them in new clients. We're going to kind of make it a rolling beta, or whatever the hell that means. But essentially, you can go and use this stuff. We've contracted with Mark Murphy to work on our docs, so none of us on the team really have to do that. And he's actually pretty amazing. If you don't know who he is, he wrote a book that people have known for a long time, and he's got more Stack Overflow points than all of us put together, maybe. So he's good. And if you it would be cool. Go check it out. Play with it. You can compile the iOS and Android apps for the droidcon sample. They all work. Tell me how great it is. Tell me how stupid the idea is. Whatever. Just give me some feedback. If you are at an organization that's seriously looking at this stuff, we are essentially turning our organization into focusing on what we call platform conversions. And that doesn't mean I'm just going to try to sell you Doppl. It means that we're trying to become very focused on how these things are going to be happening at a large, small, large orgs over the next 5-10 years, right? So that's what we're doing. And if you don't remember anything, just go to the About screen of the app, because I've taken the opportunity of the person deploying the apps to put all our information in there. So do what you can, or hit me on Twitter. I'm going to share the slides right after this. And I think that's it, unless we have any questions. Yeah. Oh.